Dear colleagues, let me introduce the result of the investigation of the group of researchers, which names you can see on the screen. The main idea of this research is the using of the geographical information approach to the assessment of biodiversity. Until recently, the most common approach to an assessment of biodiversity was the using various indexes, like Shannon, Simpson, Margolef, etc. But geographical approach has much expanded the practical application of the data. Nowadays, the methods of geoinformation systems for assessment of biodiversity are widely applied all over the world. We try to do this assessment in the Danube region of Ukraine and consider the possibilities that this kind of assessment provide for nature conservation. Danube region, one of the most valuable area. Thus, the Danube Delta was included by the WWF in the list of 200 most valuable and endangered ecoregions of the world. So it's no surprise that most of researchers concentrate the investigations within the boundaries of the Danube Delta. We consider here the Danube region in a broad aspect, based on history of the development of the delta, taking into account the past natural connection of the small steppe rivers and the Danube lakes with the unique Danube delta. So we have a comprehensive view of the region. And from this point of view, the region consists of the Danube delta and adjacent small river basins, with different landscape types that contribute to the development of rich biodiversity. The area also includes the Danube lakes, which used to be estuaries, Kagul, Kartal, Kugurluy, Yelpuk, Katlabuch, Kitai, and adjacent areas of Lower Danube. Vertebrate taxa, such as fish, reptiles, amphibians, birds, and mammals, except for Chiroptera, were chosen as biodiversity indicators. Compared with other taxa, they are more often on top of the ecological pyramid and are sensitive to the slightest changes in ecosystems. Using QGIS methods, a regular grid net was made for the region, consisting of 200 hexagons, each with an area of about 5,000 hectares. A grading scale was developed to assess species diversity of each taxa. Given the significant differences in species abundance among selected taxas, ranked scores were standardized. Therefore, the data from zoological studies were correlated with the regular net of hexagons. For the integral assessment, the method of hotspot was also used. It should be noted that the region has suffered from considerable anthropogenic transformation. West coastal areas were embanked and converted into agricultural lands. Small rivers were transformed into a set of reservoirs, ponds, and canals. Most of these activities had a negative impact on the integrity of natural communities and led to decrease in regional species abundance. The status of selected taxas of fauna makes it easy to judge the environmental process in the region, and the concentration of their species abundance can diagnose the degree of importance or transformation of various spatial areas. The analysis of the region transformation used the open data on land use classification, posted by the European Space Agency. Let's consider the obtained results. Fish. In most drainage basins, the fish species composition is extremely poor. Small rivers are drying up, but the embanked areas still preserve some species abundance and their middle reaches. Only in Kagilnik and Sarata rivers, the eastern ones in the figure, the water content of which is higher, species diversity persists throughout the entire length of their channels, but it's relatively low. Amphibians and reptiles. Suitable habitats for reptiles and amphibians are located not along the slope landscapes of small rivers, but also along numerous forest belts in agricultural lands. Birds. Birds is the basis of the species riches of vertebrates in the region. The avian diversity is represented by more than 320 species. Due to their plasticity and mobility, birds can quickly disperse within the Danube region and outside its boundaries. Mammals. The area of high mammal diversity are concentrated in latitudinal zones along the Danube floodplain and in the north of the region. This diversity is most affected by the heterogeneity of landscape and habitats. Thus, the northern part of the Danube region is located on the elevation, streaked with channels of small rivers, gullies, and ravines, with Tarutinska steppe and forest areas. This determines the high species diversity of mammals, mainly rodents. The landscape of the Danube floodplain are highly mosaic, with large areas of riverine forests, meadow ecosystems, and floodplain lakes that ensures a high species abundance of all order of mammals, typical for the region. Moreover, the border control and several reservoirs are located here, contribute to the conservation of biodiversity. An integrated assessment of the whole zoological diversity illustrates the cohesion of this natural region. The absence of any hiatuses and clear latitudinal demarcation lines from the Danube floodplain to the small steppe river basins. However, some biodiversity loss is recorded in the interfluvial areas and the middle reaches of the rivers flowing into Lake Kotlabukh and Stansovsko-Zhebrianovsky Plavny. The smallest percentage of naturalness is noted also for this region, for the rivers of Kotlabukh Basin and the Stansovsko-Zhebrianovsky Plavny. This probably explains the least biodiversity in this area for the whole region. Further steps of biodiversity conservation. Geospatial assessment of the ichthyofauna clearly shows the consequences of water flow regulation in small rivers. The current negative situation can only be solved if the water exchange between the small rivers and the Danube floodplain is restored. Natural state of channels and floodplains of small rivers support the survival of many animal species, including Ukrainian red-listed ones. Exactly small rivers and their floodplains enabling the potential expansion of the genetic exchange corridors between fragmented populations and subpopulation of animals. So the restoration here is strongly recommended. The critical destruction of steppe and meadow areas converted to agricultural lands has led to the loss of many stenobite animal species. That means that the other step of biodiversity conservation is the restoration of steppe and meadow areas. The obtained data of the biodiversity distribution enable the identification of gaps and the development of a more effective system of protected areas. The data analysis indicates the need to create at least 3 new reserves and to expand the regional ecological network. Conclusion. A large-scale geospatial assessment of the Danube region biodiversity has allowed identifying the most valuable areas. Naturally located in the Danube Delta and the lower part of the Danube lakes, and also the areas with an urgent need of restoration, which we discussed earlier. A holistic view of the region also showed the role of small steppe rivers in the species exchange and the formation of ecological corridors. Despite the significant transformation, the Danube region still remains an important area for biodiversity. Not only its key part, the Danube Delta, but also within the boundaries of adjacent small rivers basins. The use of a holistic spatial approach to biodiversity assessment provides wide opportunities for management decision making, such as identifying potential protected areas, areas for restorations, etc. This research was carried out within the framework of the European Endangered Landscape Programme and the project Renewal of Wetlands and Steppes in the Danube Delta region, which is being implemented by Rewilding Europe. The authors are grateful also to Dr. Joseph Chernichka for his valuable advice in preparing the manuscript and presentation. And thank you very much for your attention.